Hi everybody, welcome to algebra class. Today we're going to continue with our metric discussion and we're going to do some radiography applications. So make sure that you have downloaded the worksheet because the examples in the slide pack follow along with the worksheet, and that worksheet needs to be uploaded by Tuesday night at 11 p.m. And while we're going through the slides, whenever I want you to do stuff on your own to practice, just pause the video, and then once you've done it, start it back up again so you can see what the answers are. Wanted to first introduce the picture of a circuit. You're going to do a lot more of this when you are in physics, but I wanted to introduce some of the terms here. This is a basic circuit. This is the voltage source right here, which is down here, the voltage source. The symbol V, sometimes you might see an E for energy source. The unit of measure is a volt, which is right here, the volt. And the unit is V, right here. This is the resistor, right here, provides resistance to the circuit. There's the X-ray tube right here. The symbol, here's resistance, is an R. The unit of measure is called an ohm, the OHM, an ohm. And this omega sign right here is a symbol. The one we're going to be working with is current, right here. This is the current right here, which the symbol is an I, or it's typically a lowercase I, like that. And the current represents amps, or amperage, with the unit abbreviation is a capital A or a small a, typically a capital A. So we're going to be working today mostly with the current symbol right here. And current is used. Here's an X-ray machine. The current we're going to be wanting to use is in milliamps. So if you're given the current in amps, you will have to convert that to milliamps. And we need the exposure time in seconds. And that determines the number of electrons that are produced in the X-ray machine right there. And when I multiply those together, I want the product of the number of electrons and the time, and that comes up with the milliamp second, or mass. You'll hear people say mass, but it's a milliamp second. So milliamp here is my current, S is my seconds, is my time, in seconds. And again, the mass is the product of the current and the time to determine the amount of X-ray energy produced. So of course this leads us to come up with an equation. Here's my equation. To calculate mass, I need current in milliamps units and times the seconds. It has to be in seconds. So if you have an X-ray image is produced with the following factors: 200 milliamps and 0.25 seconds, what is the milliamp seconds, or what is the mass? So take a second, pause the video, and make that calculation. All right, hopefully everybody got 50 milliamp seconds, taking the 200 milliamps times the 0.25 seconds. And here's the milliamps right there, and there's the seconds right there. So milliamp seconds. Now, if the current was changed to just 3 amps, if I do the multiplying, it's amp seconds, but I want milliamp seconds. So let's convert amps into milliamps. So if amps is now my base unit, just like your gram, liter, or meter, I'm going from an amp base unit to milliamps, 3 jumps to the right. That gives you 3,000 milliamps. So now you have your milliamps. You can again calculate the milliamp seconds by doing the calculation of 3,000 times 0.25 seconds. Gives you 750 milliamp seconds. Now, the next question, if you're given 200 milliamps in 0.004 minutes, I need to find what the milliamp seconds is. But I can't do that if I have milliamps times minutes. So I need to convert this minutes into seconds. So pause the video and make that conversion. Okay, hopefully everyone got 0.24 seconds. Let me put all the answers up here. On this side I did it with unit cancellation, so 0.004 minutes multiplied by the unit conversion of 60 seconds in 1 minute. Here the minutes cancel, and you're left with seconds. Over here, I set it up as a proportion. If 1 minute is 60 seconds, then 0.004 minutes is how many seconds. You get the same answer. Now that I have 0.24 seconds, I can calculate my milliamp seconds by multiplying by the 200 milliamps. Okay, take this page. These are on your worksheet, the first 8. So go through all of these and come up with the answer and pause the video. And when you have them all done, we'll continue and I'll go through each of them. All right, for the first one, 200 milliamps times 0.4 seconds is all you needed to do. So you get 80 milliamp seconds. The second one, 50 milliamps times 0.02, just multiply, 10 milliamp seconds. The third one again it's all in milliamps and seconds, so we're just multiplying, so 6.8 milliamp seconds. And the last one I have milliamps, and I do have seconds, but it's 1/4, so let's convert that to 0.25. It's hard to write with this. 0.25. 0.25 seconds, which you get 150 milliamps. Now down in the last 4, this is in amps. So we need to convert that to milliamps by moving to the right 3. So that ends up being 300 milliamps. 120, 1 divided by 20 is 0.05. So now I can multiply. This one, 400 milliamps. Yes, that's milliamps, so I'm happy. This is in milliseconds. I only want seconds, so I need to convert that to seconds. So 400 milliamps times 0.002. Seeing it's millis, I need to go back to the base. My base now is seconds, so move it to the left 3 times. With this one, I have amps, so convert that to milliamps by moving to the right 3. And here's minutes. So now I have to convert 0.05 minutes to seconds. So I did it all as unit conversion, so 60 milliamps, because I took the amps and moved it to the right 3 to get milliamps, multiplied by 0.05 minutes, and then I'm going to multiply that by 60 seconds over 1 minute, or 60 seconds per minute. I'll put this down here per 1 minute. So now minutes are canceling out, and I'm left with milliamps and seconds to get milliamp seconds. So 60 times 0.05 times 60. The last one, this is already in milliamps, but again I have this in minutes, so I have to do that same conversion. 200 milliamps times 0.005 minutes times 60 seconds per minute. Again, the minutes cancel out, and you're left with milliamp seconds. So here you have an equation, milliamps times seconds equals milliamp seconds. So the current in milliamps times seconds equals your milliamp seconds. So for all the previous page, we were given the current and the time and multiplied to come up with the milliamp seconds. Now with this chart, with the first three, you're given the milliamp seconds and the current, and you have to come up with the time. So now these will be division problems. Just like 100 times x equals 75. So you will divide 75 by 100 to get the time. And in the bottom three, you'll do the same thing. X times the time equals the milliamp seconds. So you're solving the bottom for x as well. So pause the video and calculate those 6. So for the first one, you should get 0.75 seconds, then 0.2, 1.5, and for current is 1,000 milliamps, 300 milliamps, and finally 220 milliamps. So this is a graph of all the units that you will be working with. So we have the exposure is in, I call it R's because I can't pronounce that word. Absorbed dose, rads, dose equivalent in rem, and activity in curies. I have the international unit in this column for the exposure. So here's the conventional unit for exposure is the R, Roentgen, and the international unit is a coulomb per kilogram. So again, we have the slash in there, so it's a coulomb is a C, that's a unit of charge. So C, coulomb per kilogram, which is the slash. And if it's in the denominator, you can also see it right here written with the -1, because we're going to bring it up to the numerator. So that's coulomb per kilogram. The -1 means the kilogram is in the denominator. These last two columns are conversion factors between the conventional unit and the international unit. So here, 1 coulomb per kilogram is equal to 3876 R's. Or I can say 1 R is equal to 258 microcoulombs per kilogram. See that little U in there? That means micro. So here the absorbed dose is in rads, is a conventional unit. The international unit is a gray. And 1 rad is equal to 0.01 gray is a conversion factor. But what if I wanted to know what 1 gray is equal to? So what I would do with this equation is I would divide 0.01 on both sides. So 1 gray would end up being equal to 100 rad. So you can use either one of these conversion factors when you're converting between a rad and a gray. With the dose equivalent, conventional unit is a rem, the international unit is a sievert, and 1 rem is equal to 0.01 sieverts. If I divide both sides by 0.01, I can get 1 sievert is 100 rem. And then activity with the curie. Here we have a curie or a becquerel. I can't pronounce that one either. But here a curie is 3.7 times 10 to the 10th becquerels. Or here a microcurie, a millicurie is 37 megacuries, megabecquerels. We'll never use that one. I'm mostly going to be dealing with these two right here in terms of unit conversions. So if you go to your worksheet, we want to convert 8,000 rads to a gray. You're going to do the exact same process that we did with, say, converting inches to feet. What is the unit conversion factor? Based on the previous slide. And how are you going to convert it? So I could take 8,000 rads. And I know from the previous slide the conversion factor is 1 gray is 100 rads. So you can multiply those using unit conversions. Rads cancel out, and you're left with 80 gray. Let me put all these on here, because I also did it in proportion, setting up 1 gray as 100 rads is equal to how many grays over 8,000 rads, if that's the way you like to do the conversions. The 450 rem to sievert, so I'm starting with 450 rem. What's my conversion factor? 1 sievert is equivalent to 100 rem. If I multiply those, the rems cancel out, and you're left with 4.5 sieverts, because it's 450 divided by 100. Just like this is over 1. Or if you want to set up a proportion, 1 sievert is to 100 rems is equivalent to X sievert over 450 rems. The third one, I'm going from a rem to a millirem. So now my rem is my base unit. So to go from a base unit to milli, you're just going to the right 3 times. So 42,000 millirem. The last one, 705 millirem to a sievert. First, what I did, because my conversion is 1 sievert to 100 rem, and I have to make sure my rems cancel, so I converted 705 millirem back to the base 0.705 rem. Then those can cancel out. If I multiply that, I get 0.00705 sieverts, and that's just to show that you can take that as a base unit to millis. I moved it to the right 3 times to get 7.05 millisieverts. And here I also set it up using a proportion. 1 sievert is 100 rem is X sievert over 0.705 rem. Note, I need them both to be rems. All right, let's do some applications. So an upper GI exam is performed at 3 milliamps for 20 seconds. What is the total exposure in R's? This is what I'm looking for, R's, if the patient's exposure rate is 1.2 R's per milliamp seconds. Here's a rate. Typically when you have a rate, you're going to multiply this number by something. What am I multiplying it by? Whatever's in the denominator. So I need milliamp seconds. I can find milliamp seconds given these 2 pieces of information. So let's find the milliamp seconds. 3 milliamps times 20 seconds is 60 milliamp seconds. Now I have milliamp seconds, so I can take the unit rate, which is 1.2 R per milliamps, and multiply that by milliamp seconds. Here they cancel out, and I get 72 R's. This is just like taking 30 miles per hour, multiplying it by the amount of hours to get how many miles. It's the same thing. Whenever you have a unit rate, you're looking for this slash or this per right there. That's indicating a rate. Okay, next one, a fluoroscope examination requires 3 minutes of exposure time. So I'm going to underline things, 3 minutes. If the exposure rate is 250 milli-R per hour, what is the approximate exposure for the 3-minute procedure? So again, this is a rate, milli-R's per hour. So I'm going to be multiplying this rate by the total number of hours. But what do I have? There's 3 minutes. So first, convert minutes into hours, and then multiply. So pause the video and try that one. All right, to convert 3 minutes to hours, it's going to take the minutes and divide by 60 to get how many hours. And you're going to multiply that by 250. I did that, I got 0.0, oh that was terrible, 0.05 hours. And then you can multiply that by 250. Minutes cancel here, and then my hours cancel here, and you're left with millihours. And note here, my answer is in both hours and millihours. So when you're doing these questions, which I got out of a board exam, I start with this and I go, well, it's already in millihours, so I can pretty much guess between these two if you have to guess. Because I've started in millihours, and if I'm going to multiply by hours, I'm going to be left with just exposure time. So those are my best two guesses. Okay, next slide. If a patient receives 200 millirad, right here, the M in front of it means milli. During a 10-minute examination, what is the dose rate? So if now I'm finding a rate, it's going to be a division problem, something divided by something else. So I'm looking at my answers here, and all the answers are in rad divided by minute. But you are given millirad. So before you do anything, we have to convert this into a rad. So if I'm at millirads, which is to the right, I'm bringing it back to the left, 3 places back to the base unit, and you should get 2 rad in 10 minutes. So here's 2 rad. And if I'm trying to find a dosage rate and I'm looking at this, this is saying rads divided by minutes. So I'm using my answer to tell me how to do the problem. So take the 2 rads divided by the 10 minutes, and you get 0.2 rads per minute. And the next one, if a patient received 0.9 rads during a 3-minute fluoroscopic examination, again, what is the dosage rate? I'm going to look at my answer first. I need millirads divided by minutes. Well, I'm given rads. So first off, I need to make that a millirad. And then I can divide by minutes because that's already in minutes. All right, so that's the end of part 1. So close this slide pack and open up slide part 2.